Good morning. It's time for some more math today. This is College Preparatory Mathematics Core Connections 3, problem number 1-12. And if you know Joel Bowler, Joel Bowler, Dr. Joel Bowler from Stanford, this is one of her most favorite types of problems. It's called the How Does It Grow problem. I'm going to read the problem directly from the textbook. It says, examine the tile pattern on your paper, sketch figures 4 and 5. How does the pattern grow? Explain how you know. And the last problem, how many tiles will there be in figure 100? Explain how you know. Explanation is really, really important in mathematics. You always have to explain, justify your work, show your work, write a sentence, etc., etc. You'll notice today that I have two types of pens. There's the bold pen and there's a fine tip pen. These are Muji gel ink tip pens at 0.5 point. And I love these pens. These are my favorite pens in the world. They're great. Muji is awesome. So let's start. So figure 1 has 3 tiles here. Figure 2 has 5 tiles. And figure 3 has 4 going down plus 3 more, so 7 tiles all together. We need to sketch figures 4 and 5. So what's the next pattern? Let me use red for figure 4. So it seems to me as each time the vertical part of the L shape is growing by 1. There's 2 in figure 1, and then there's 3, and then there's 4 in figure 3. So the next shape I am going to draw down here. Let's start right here. Say 1 block, 2, 3, 4, and 5. I think it's going to be 5 blocks since the L shape is getting bigger and bigger each time. It's still going to be a single block going this way. And then going the horizontal part of the L shape is also 1, 2, 3, 4, 5 blocks. You can say that there's 4 blocks sticking out. You can say there's 5 total across the bottom, 5 total going up and down. There's 1 block in the corner where they overlap. Okay, there you go. That's what I think figure 4 is going to look like. And I'll use my Muji pen, the finer tip pen, to label figure 4. Okay. Looks right? Each time it's growing bigger. Alright, let us figure out how to sketch figure 5. Figure 5, let's choose a purple that matches. I think this one will match. It might be a little bit lighter than my Muji purple. Alright, figure 5. Let's see. Well, if there's 5 blocks going down in figure 4, let's say it is going to be 6 blocks going straight down. 1, 2, 3, 4, 5, 6. Graph paper is super handy. Graph paper is awesome. This is a 10mm graph paper that I bought on the same day as the Faber-Castell pens. 1, 2, 3, 4, 5, 6 blocks going across the horizontal part of the L shape. Separate the blocks. Once again, your drawings do not have to be perfect. I really should use a ruler here, but since I have graph paper, it's alright. Okay, figure 5. Let's label it. Label your diagrams, everyone. Label your diagrams. Yep, yeah, figure 5. The Muji pen's purple is slightly darker than the Faber-Castell purple. That's okay. Close enough. Alright. Close enough for our purposes, I should say. Sometimes it isn't close enough for our purposes, no matter how accurate. You can try to draw it by hand. There we go. That's the first part of the problem. The second part of the problem. Okay, let's figure out how many tiles there are in tile 100. Well, now there's lots of different ways to do this. The very first, I'll show you two ways. Excuse me. The first way that I thought of doing this is to make a table. Figure number on the left-hand column. and number of tiles on the right hand column, because there has to be a pattern here if we're trying to figure out how many tiles there are total in the 100th column. There has to be a pattern between the figure number and the number of tiles shown. Now I want to do something strange here. I'm going to skip my first line, leave a blank. I tend to always do this anyway, no matter what, because sometimes when you're trying to look for a pattern, you want to go backwards as well as forwards. In this case, we will start by going forwards, and we'll see where that goes. Okay, figure number 1 has 3 tiles total. Directly from a picture. Figure number 2 has 5 tiles total, and figure number 3 has 7 tiles total. So that's our pattern so far. The one that we drew, figure number 4, how many tiles does it have? Go ahead and count it yourself for now as I get my pen ready here. Did you get 9? 1, 2, 3, 4, 5, 6, 7, 8, 9. Me too. 9 for figure 4. And figure 5. How many tiles does this one have? Okay, I hope you got 11, because that's what I got too. I wish that we can talk to each other through video so that you can double check my work. Alright, so let's take a look at the table here and see what kind of pattern we find. What do you think? Take a moment to look carefully. Okay. You can even pause the video if this is going a little bit too fast. Sometimes a lot of my students tell me that I go much too fast for them in class. I am right now capping on my pens. I might have to use them again, but just in case, I don't want the ink to dry out. Okay, so I'm going to show you something here. If we were to go backwards and say we used a theoretical figure number 0, how many tiles would that be? Yeah, I guess 1 as well, right? Because a change in the number of tiles seems to mean you're adding 2 tiles each time, right? While the figure number goes up once each time. From 1 to 2, from 3 to 4, from 4 to 5, etc., and so on. It's going up. The number of tiles are increasing by 2 for every figure that we have. Okay, so a lot of teachers will start teaching you by writing an equation. This problem you don't necessarily need to, but since we made a table, I might as well do it anyway. In slope-intercept form, y equals mx plus b. Excuse the vertical and the horizontalness of it. Okay. If figure 0 usually is our y-intercept. The y-intercept is where the line touches the y-axis. And I know, by the way, I know this is linear as well because the pattern is consistent. It's constant throughout all what I know. I'm going to assume that it is going to be linear. Okay, and the y-intercept is going to be 1. Okay, when the x value is 0, the y value is 1. And this is going to be a review lesson later on. For now, just I hope you trust me that the y-intercept is 1, so plus 1. And the slope, the change in the y values over the change in the x values, I'm letting the y values be the output and the figure number be the input. It's 2 over 1, so that's 2 times x. Y equals 2x plus 1. I'm going to turn it this way as slope-intercept form. So if my figure number was 100, if I had 100th figure, okay, that means the x value is 100. Multiply it by 2, according to the pattern that we found, 200, plus 1 more. That's 201. We're going to guess that there are 201 tiles in the 100th figure. A lot of it came really abstractly. So the second way to do this is to take a look at the pictures again, right? Visualize it. The picture is always super helpful. What do you notice? What is happening here? Well, there's a lot of different patterns. I had noticed, this is the one I noticed. If you have any other patterns, let me know in the comments. I noticed that in figure 1, there's 2 units going vertical. In figure 2, there are 3. In figure 3, there are 4 units vertical. You can also look at the horizontal bar, but I'm looking at the vertical part of the L shape. And do you see? Right? 2 is 1 plus 1 more. 3 is the figure number plus 1 more. 4 is the figure number plus 1 more. 5 on the 5 on the 4th figure, excuse me. And 6th little boxes going on the vertical part of the L shape in the 5th figure. So I am going to draw a guess, just a mini guess. This is not to scale, this shape. A regular old L shape, and this time I'm not going to delineate the boxes. In figure 100, I am going to guess that along the vertical part of the L shape, there's going to be 101 boxes because of the pattern that we saw previously. There's 1 more than the actual figure number. Alright, so if this vertical L shape has 100, that means this part right here is 1 box. That's the pattern, the width of the vertical and the horizontal shape, parts of the shape, has a width of 1 box. It's not like a double line box. So I'm not going to count this bit right here. It's already been counted. I'm just going to draw an X on all of the corner pieces here. It has already been counted. But I do notice, going back to figure 1, hey, look, there's 1 box. Huh, interesting. 1, 1. Does that happen here? Yep, there's 2 boxes going the horizontal way, the horizontal part of the L shape. There's 3 boxes in figure 3, not counting the corner box. Remember, we've already counted that one when we counted vertically. There's 1, 2, 3, 4. 4. Oh, in figure 4. Whoa, and 5 little boxes in figure 5. Huh, interesting. So my hypothesis is that, not counting the corner piece, which we have already counted, I'm going to say in figure 100 there's going to be 100 boxes going the horizontal way, minus this part. Okay. So altogether, 101 plus 100 gives us a total of 201 boxes for figure 1, which matches what we found in our table. And if you did a problem 2 or 3 different ways and your final answer matches, it's probably correct. Probably, assuming that you did the methods correctly. This is an awesome problem, since we can look at it visually and find the answer, as well as find an answer algebraically, looking at a pattern in the numbers, figuring out y-intercept. You don't even have to figure out slope-intercept form. You can just go straight here after figuring out the pattern and just keep counting up. That's how you do this type of problem. Hey, I'll see you next time. Thanks for watching.